In this video, let us study how to convert a number which is expressed in the decimal form to P over Q form. Now before we go there, let's get a little clarity on how decimals behave, on how decimals look like. Now let's say there is a decimal, so decimals are of three kinds. The first is a number like this, 4.75. Now you notice that after decimal there are two digits, and there is nothing which, there's no digits which continue until infinity. This is called a terminating decimal, right? However, there could be decimals which look like this, 4.75555, and the 5 continues until infinity, right? So these are also expressed as 4.75 with a bar on top of the 5, the digit 5, signifying that 5 is repeated infinitely. Now this is a non-terminating decimal. However, because there is a pattern of digits which is repeating, this is also recurring, right? So this kind of decimal has two properties, non-terminating and recurring, right? These digits, these decimals have just one property, they are terminating. There's nothing to recur, no digits recurring. Another example of non-terminating and recurring, it may look like this, 7.84343343. Now interestingly, this time the digits 434343 are recurring all the way until infinity. So this is, again, it is non-terminating because of these dots, and it is recurring because there is a pattern 43 which is getting repeated, and I'll just simply express this as 7.8 and 43 recurring. So for the recurrence of 43, I'll put a bar on top of both of these digits. So this signifies the recurrence of 4 and 3. So 4343, right? The next kind is, it looks like this, 8.48239187, and so on and so on, and it goes on. So clearly it is non-terminating as well. Like last time, it is non-terminating. However, unlike last time, this is not recurring. Now, by not recurring, I'm simply saying that here there was a strict pattern of digits which repeats itself infinite times. Here there is no pattern. Now you notice that after 8 there is a 2, but here after 8 there is no 2, there is just another digit 7, right? So this gives away that this is an irrational number. Now it's difficult to say what kind of an irrational number this is, whether this is a square root or a cube root or a 5th, 7th, 70th root, we can't say. But what we can clearly say is that this is an irrational number, and clearly irrational numbers cannot be expressed in the form of P over Q. However, both the first and the second type, they are both rational numbers. So we'll ignore this, right? Clearly irrational numbers cannot be expressed in the P over Q form, and that's how the definition goes. Rational numbers are expressed in the P over Q form, so we'll look at both of these one by one and try and convert both these numbers into rational numbers. Now, to convert 4.75 into a rational number, now we notice that this is a terminating digit, the terminating number. So all we need to do is we need to convert 4.75. We just need to write this as 475 divided by 100. Now why 100? Because for two decimal places, for two digits after decimal places, we've just put two zeros and then we can remove the decimal, right? So what we can do after this is we can, cut and slash and find out all the common factors, cut them down, and we finally end up. So I guess 25 is a common factor. 25 1 the 25, 2 25, 25 9 the, and 25 4 the. So 19 by 4, right? So we've converted 4.75 into P over Q form. So not so difficult, right? But there is some problems that we can face in converting the recurring digits into into P over Q form. Now, before we get there, let's do a small little exercise, right? Let's look at some basic divisions so that we build our theory around it. Now, what's 1 divided by 9? 1 divided by 9 is, because 1 is smaller than 9, so I straight away put a decimal, and this is now after I put a decimal, this becomes 10, so 1, 9 1 the 9, and I get 1 remainder again, and I do a 9 1 the 9 again, and 1 1 1, and it continues all the way till infinity. So 1 divided by 9 can be expressed in the decimal form 0.1 bar. Likewise, let's look at 2 by 9. Let me do the long division to show you more clearly. So I'm dividing 2 by 9, so I put a decimal straight away to make it a 20, and 9 to the 18, and I get a 2 remainder, and I can put a 0 here, and to the 18, and you notice that as soon as I divided by 2, I multiplied by 2 and I subtract 18, I get the same remainder as I started from, right? And I will continue to get this 2 remainder infinitely. There is no end to this, right? So this is 0.2 bar. Similarly, 3 by 9 we all know is nothing but 1 by 3, and it is 0.3 bar, and by this logic you would notice that 4 by 9 is 0.4 bar, 5 by 9 is 0.5 bar, 6 by 9 is 2 by 3 is 0.6 bar, 7 by 9 is 0.7 bar, and 8 by 9 is 0.8 bar. Now it's interesting to note, if by this logic, what can I say about 9 by 9? So by this logic, 9 by 9 should be 0.9 bar, and actually if you continue this until infinity, 0.999 until infinity, you actually end up with 1. So this is how division by 9 goes. So any digit less than 9, when it is divided by 9, just repeats itself until infinity, right? Let's look at how it works with 99. Let's look at a number, let's say 12 or 13. Let's divide 13 by 99 and see what happens. So 99, 13, of course decimal, right? So we get a 0 here, we get to put a 0 here. So 99 1 the 99, right? So I'm left with a 31 remainder, right? Then 99, I'm allowed to put a 0 here, 99 3 the, so this is 297, and I get a 13. So just like it was happening here, when I divided by 9, the remainder was getting repeated after every division, after every multiplication and subtraction operation. After every operation I was getting the same remainder. When I divide by 99, after every 2 operations I'm getting the same remainder. So that's fairly straightforward to say that 1 3 1 3 1 3 1 3 1 3 will continue until infinity. So 13 upon 99 is 0.13 continued until infinity. Likewise, 80, let's say 88 divided by 99, right? So this is going to be 0.88 repeated until infinity. But you notice that I can cancel out 11 on both numerator and denominator. So this is 8 upon 9, and 8 upon 9 is anyway 0.8 bar. So same thing, right? 0.8 bar. So by this logic, it doesn't matter whether you have a 0.8 bar or you have a 0.88 bar, it doesn't matter. But having said that, the point being made here is that anything divided by 99, 2 digits will get repeated. Now let's take another case. What happens if I divide, let's say 7 by 99? Now what happens? Let's do the long division and see. So I have to put a decimal. This is 70, still not greater than 99. So I have to put a 0 here, and that allows me to put another decimal here. So 99 into 7 is 693. And now I'm left with 7. So you notice that we get the same remainder, but after an extra 0 is put. So now what is going to happen? I started with 7, I got a 7. So when I started with 7, I ended up with the same remainder after 0, 7. So it's going to be 0, 7, 0, 7 and so on until infinity. So again, when there is a single digit number being divided by 99, I still get a repetition of 2 digits. So instead of a 7 being repeated, now it's 0.07 which gets repeated. And you can continue to extend this logic. Let's say 127 divided by 999 will give us 0.127 repeated infinitely. 3 nines means repetition of 3 digits. 4823 divided by 99,999. Now denominator tells me that there's going to be repetition of 5 digits. I see only 4 here, so I just put a 0, 4, 8, 2, 3 and repeat these 5 digits, right? So this is how division by numbers with all nines happens, right? Now this actually gives us a lot of clues into how we are going to compute numbers which have recurrence, right? So now let's take an example of recurrence. Now let's say there is a number like this, 0.47 and 47 repeated. Now I can just straight away go ahead and say that this equals 47 by 99. If there's anything common, I would just cancel out and get done with it. However, if there is a number like 1.37 with 37 repeated, not so difficult. I can separate 1 from 0.37 repeated, right? And this is going to be 1 plus 37 by 99, and I can have a mixed fraction, or I can just multiply 99 with 1 and add to 137, so I get a 136 by 99, right? So this is how you will do recurrence, but recurrence can get a little bit more complicated than this. Now what happens if there is a decimal like this, 0.487, and this time only 87 is getting repeated, not 4, right? So again, if we have to use the same methodology, what we will do is we will separate out the 0.4 and 0.0 with 87 getting repeated. Now I'll leave 0.4 here for now, and I'll multiply and divide this 0.0 with 87 repeated, multiply and divide by 10. Now this becomes recognizable, right? So now you recognize this is 0.87 repeated divided by 10. Now this I can solve. So this becomes 0.4 plus 0.87 repetition of 87 gives me 87 by 99, right? And this 10 comes here, so I get 0.4 plus 87 by 990, right? I can do this 4 upon 10 and end up with a mixed fraction, so this becomes 4 by 10 plus 87 by 990. I can take LCM 990, so this is 10 into 99 is 990, so this is 4 times 99 plus 87. 4 times 99 is 396 plus 87 divided by 990, and I get, this is 13 short, so this is 483 by 990, right? So this is how I would do this, but there is a shortcut, and it's best you memorize the shortcut to arrive at this answer straight away. If we have a number like this, 0.4 with not the entire thing repeated, not the entire thing recurring, only the 87 recurring, what I would do is I would write in the denominator, I would straight away write 9 and 9 for 2 digits being repeated, right? So there's 2 digits repeated, 8 and 7. For each of these digits, I put a 9 and a 9. For the number of digits which are not repeating themselves, there is just one. Just 4 after the decimal is not repeating itself. I put a 0 for 4. Now, the numerator becomes 487, the entire thing, minus the number formed by the non-recurring digits 4. So this is 483 by 990. Straight away I get my answer. Let's take another example. 0.52873 with only 873 repeated, right? So I'll write my denominator first. My denominator is going to be 999, right? 3 recurring digits, so 19 for each recurrence. 2 non-recurring digits, 2 zeros, 1 for each of the non-recurring digits, and numerator will have 52873 minus 52. So this gives us 52821 divided by 99900, right? So we can cancel out if there's anything common and get done with it. So this is how we are going to convert non-terminating and recurring digits into P over Q form.